Welcome back, Virtual Precalculus. In this lecture we're going to learn about different statistical measures. And what we mean by that is often you have a population of things, test scores or people or whatever, and it's really a complicated group of numbers and information. And someone may ask you, well, what's the main point? Like, what's the average? Or they may want you to sum up the whole distribution of information with a single number or a single piece of information. And that's what these tools try to help us do. We have to use them with caution. And there are two basic kinds of tools we're going to talk about today. The first are measures of central tendency, things like mean, median, and mode, and you already know a lot about that stuff. And then something called measures of spread or dispersion. And the three we're going to talk about are range, interquartile range, and standard deviation. And just again to emphasize that these are like shortcuts or summaries of a large amount of information. So starting with measures of central tendency, good old mean, arithmetic mean, to find the average or mean of a population of things. You just add them all up and divide by the number of things. That's the arithmetic mean. There are other kinds of mean, which you'll see if you work on this week's stretch problem. Anyway, this thing in statistics is often called x bar because it's x with a bar over it. That means the average x or the mean x. And we can use summation notation to write this more compactly as the sum of all x's divided by the number of things in the sum. Okay, and that's fine. I mean, why not just leave it at that? That's a great way to summarize a bunch of numbers. Just give someone the average. But the problem is that the mean can often be distorted by an outlier or by an extreme value. So just to illustrate that, suppose I ask 10 people how much money they have. Okay, and I just made these numbers up. But here they are in order, in increasing order. And you can see most of them are in, between 20, 30, 40, 50,000. And then I happen to see Bill Gates, and he happens to have $42 billion. So if I find the mean of these 10 things, well, it's going to be just about, not exactly, but just about $4.2 billion. So is that a good summary if someone says, well, what was the average amount of money, like how much money do these people make? And I say, well, there were 10 of them, and they say, no, I don't want to know all 10, just I want to know how much money they make. And I say, no, it's complicated, and they say, I don't care how complicated it is, give me a number. So I give them the average, the mean, $4.2 billion. Well, this person's going to go away thinking, wow, that was a room full of 10 billionaires in there, that's cool. And really, that's not true, right? There was just one really rich guy, and his money skewed the entire average, okay? So there's a better way in this kind of a situation to summarize this data set. And this is a perfect job for the median. The median, as you remember, is the middle number when you line them all up in order. Okay, and the median is a lot more immune to being skewed by extreme or outlier values. So if we just look at these, I mean, there are 5 in the top row and 5 in the bottom row. So because there's an even number, there are really two middle numbers. In this case, 45,000 and 50,000. Okay, well, in that situation, all you do to find the median is just average, or find the mean, of the two middle numbers. Well, the average of 45 and 50 is 47.5, so 47,500 is the median amount of money. Okay, now, if the person asks you, well, how much money did these people have, and you tell them 47,500, they're not going to realize that Bill Gates was there. So maybe the best way to describe this situation, the most appropriate way, would be to say, look, the median income was 47.5 thousand, but there was this crazy guy, this outlier with 42 billion. Okay, and so because it was kind of a complicated distribution, it requires more than one piece of information. Last but not least, the good old mode. Mode, like a la mode in fashion, mode is the most common or the most frequent result, and it usually is applied to qualitative rather than quantitative information. It doesn't usually find much of a place with quantitative information. Final point about these measures of central tendency is that in some situations they are all the same. If you have a distribution of information that is absolutely perfectly symmetric, then as you can see in the diagrams in your book, the mean, median, and mode will all be in the same place. But if the distribution is skewed at all, in which most realistic distributions are, then they won't always necessarily line up. A skewed right distribution tends to have the mode below the median, which is below the mean. The mode is always the highest point in a distribution. And a skewed left distribution has the opposite situation. The mean tends to be lower than the median, which tends to be lower than the mode. So just good to keep in mind that they're not always the same, although they can be very close. And they can, in a symmetric distribution, they can be exactly the same. Okay, so measures of spread or dispersion. If you look at these two symmetric distributions I've sketched here, they obviously have the same central tendency. They have mean, median, and mode of 50. But there's something different about them. I mean, what is it? You know, the one on the right is fatter than the one on the left. So that's something important and interesting. If these were test scores, then in both situations the average score was about 50, but in the situation on the left, there was a very small departure from that value of 50, whereas on the situation on the right, some people did very, very well, and some people did extraordinarily poorly. So that's different, and it would be an interesting thing to include in a summary of those data. All right, so let's suppose you have 32 test scores. These are not the ones represented above in this list here. Okay, 4 rows of 8, so it's nice and easy to see. The first and really easiest way to summarize the spread or dispersion of these values is to talk about the range. And the range is just the largest value minus the smallest value. So in our case, 98 minus 35. And that just gives you an idea of, you know, how far out the scores go. So 63. The next most complicated one, and the next hardest to calculate, is the IQR, or interquartile range. Okay, now this may be familiar from MathMade. The old nightmare has come back. The interquartile range is the difference between the third quartile and the first quartile. What the heck is that? Well, the median splits these numbers in half, right? In this case, what would the median be? Well, 67.5, right? Because you've got two middle numbers, 67 and 68. Anyway, so you've got the top half and you've got the bottom half. Well, the third quartile is the median of the upper half, the highest half of scores, right? So what's the median of that half? Well, again, there are two middle numbers, so it's, you know, 75 and 72. The average of that is 73.5. And then, well, what's the median of the lower half, the smaller half of scores? Well, 56, right? And so the interquartile range is just that. It's just the difference between the third quartile, which is the median of the upper half, and the first quartile, the median of the lower half. In this case, 17.5. And it really tells you kind of how fat the thing is, how fat the distribution is. A larger interquartile range corresponds to a wider spread, like the diagram on the right up above. And a smaller interquartile range corresponds to a smaller spread, a more narrow distribution like the one on the left up above. There's one final and very useful measure of spread that we need to discuss, but there's no room in this video, so we're going to talk about that in part 2, and that is the standard deviation.